Right. Happy Christmas. Merry Christmas, I mean, of course. So I have this little cube here. And I want to solve it. How many states does a thing like that have? I think it's half of what you can do by just taking it apart and putting it back together or something like that. And doing that looks like the permutation of 8 cubes. And each cube then has a rotation of 3 possibilities. That's a lot of states. Or maybe see it immediately as a matrix. How about there are certain colors that must be opposite, and I guess that if they are opposite, there's not a single block that has those 2 colors on it. You know what? No fancy formatting, I'm just going to I don't know, let's call it optimistically solve. Okay. The mandatory hello world. Slight variation on it. And how we compile it. And then we can run it. And that worked. Wow, we have our first program. Time to add a class. So the thing exists of 8 pieces. Let's just call them pieces. And then a piece exists of 3 sides, where each side consists of one of 6 colors. Class. Yeah, I might as well call that an enum. No, we're going to call everything a class. That's a good programmer would do. But eventually an enum is probably pretty handy. So which colors do I have? Well, red I see. And I see yellow. And green. And what else do I see? White, I think. Blue. Did I miss one? I must have missed one. Orange, yeah. Yeah, we need a function to print them, right? Yeah, I never get here, but maybe don't complain. Already contact. And maybe abbreviations is gonna be handy. Do they all start with different characters? I think so. Otherwise I wouldn't have been this fast with sorting them. Alphabetic order. Would have been a problem. I'm just kidding. Yep, yeah, all of them. Character. You should be able to construct a color from the enum type. Not super happy that it's called color though. Let's call it e-color. So I can use color as a variable name. Color, const reference, painting a color, return OS, full name, short name, full name I guess for the OStream operator. So just write the name, color string, color underscore from color object. Okay, let's create a color red. That makes no sense whatsoever to me. What is its problem here? Yeah, expected missing comma, that is the problem. Oh yeah, I reordered them after having orange at the bottom. That was the problem. Solve. Red. Oh, that works. So we have colors. Now, a piece exists of 3 colors. In no particular order, really. Although... Hi, Mr. Birkaimerito. Yeah, I wanted to pick that nickname as well, but it was already used. Especially the Z6C got me. A bit surprised. So my single piece well has 3 colors. So let's use an array. Color. And give it a size of 3. Call it sides. Oh, that requires us to include the array. There's more that I want to do with color though. I want to be able to compare them, like unequal. I like to keep these, I don't know, binary operators. I like to keep them as free functions. So let's make it a friend. Yeah, so let's say also construct is not really needed, but well. Okay, so that is another friend then, which then just returns the comparison of the internal variable, aka enum, under the hood. To color, and then we can do the exact same thing again with I think, well, we might need a less then. Voor in heel handy voor associative containers, like standard map maybe. How am I going to construct a piece? But there was only a fixed number of pieces, so I think I want to construct it from an array. Fixed array. So yeah, in the end, we just have, I don't know, some constructor that takes an initializer list, but initializer list with enum, color enums in it. So maybe I can use that thing directly to initialize sides, to initialize another array, which we then copy to sides. Maybe I should use a construct here as well, but yeah, I'm just going to construct them anyway. From an initializer list, I mean. So let's try that. Let's just make another array. I know the size. So array of pieces. Hey, now we have 8 pieces. Yeah, I'm just looking at my cube, and I'm seeing, for as far as it's not totally dark here, white. Let's go clockwise. So white, blue, red. Maybe also alphabetic, so it's more like start with blue because of the B, which is the order in which I put these things. So the smallest enum first. And then it's blue, red, white, clockwise. No, what do I have here? Blue, yellow, orange. Blue, yellow, red. What is this? Green, red, yellow. That was the top. Take this thing. I'm going to blue, orange, yellow. And then this one is green. What the hell is that? White or yellow? I think white. Green, white, red. And then we get green, orange, white. And already the last one. Blue, white, orange. Okay. Well, does it compile? I don't know. Probably not. Nope. Oh, you check because I can't type. It's something else. Orange. Too many initializers. Why you count to 8? What the hell? Probably just missing parentheses. My first guess is add parentheses around this. Substitute that with twice of them. 2 of them. And then again, but now for the closing ones. Too many initializers. How can this be too many initializers? 1, 2, 3, 4, 5, 6, 7, 8. Okay, then the big trick, because nobody has any clue what is going on. We just say that these are pieces. It's going to say anything but too many elements now. Because, well, I have literally 8 pieces here. And the thing stores pieces. But don't ask. I don't want to know. That's unbelievable. Yeah, erase and nasty to initialize. Maybe you can fix it with having an initializer list here, but hey, this is just a quick, very quick in-between thingy for Christmas night. So as long as it compiles, I'm happy. Now we have 8 pieces. Okay, what's next? Want to print pieces. Maybe do some testing with them. So I can print all pieces. Let's say int p is 0 to p is less than 8. Yeah, 8 even. Plus p. Run over all pieces. Print all pieces. What are my pieces? Well, that is pieces then. P. Now this definitely prints pieces. And we can't print pieces, so let's add that. Add a friend that can print pieces. Return. Well, let's print a piece as 3 times, I don't know, let's say for S is less than 3. The S stands for side. Print the content. So we're talking now about piece dot sides, which we have access to because it's the front. Side S to be precise, and then we don't want to print the color using this one because that would print str. I want to use gr, just colored gr, which means we need to get access to eColor or have another member function to color. Well, okay, let's hide the eColor more or less. I'm just making it up as I go. I'm just gonna call it print on. Print on now does normally I don't have this and then some global thing catches it and calls that. And now I'm using it as 2 different things because it's not depending on my utils library. So I have to be, I can do things that I normally can't do. Dirty things. So I'm going to call print on this object world. And that should print 3 characters for 8 pieces. And one of the pieces is called boy. How about that? Blue, orange, yellow. I never looked at it that way, but yeah. Well, interesting. Let's count the number of colors that we have in total. There should be 4 of every color. There's it's an I don't know, test-ish thing. In order to count it, we must have access to everything, though. Again, let's run over all colors. Oh, that's not going to work. I'm going to try really hard not to use my standard utilities, which I'm already yearning for now. I think you can run over eColors, so see you cannot hide the eColors apparently. Pol.c, and then we begin with blue, and then we do c is unequal. No, that's not possible, man. How can you even run over all equals? Okay, let's just do dirty then. Let's call run over colors as integers. How many colors were there? Yeah, obviously 6. Okay, let's hard code that in. This is totally not how to do it. But maybe as a beginner it's not bad. Plus C, so okay. At least my loop loops over 6 things. I do want to get an enum though, so color enum color is static cast the C to equal. Ouch. Or is that reinterpret cast? I can print those as well, can I not? Or as well, I can print them. Put it that way. 0, 1, 2, 3, 4, 5, 6. Not exactly what I expected. Oh, that's the equaler. Yeah, okay. So then after that we have to construct a color. Probably from the EC, and then we print the color. Yeah, now they appear as names. Yay. Oh, my cursor at least knows what they are. Well, having my class color, I can say okay, now run over all the pieces and then count, well, detect if they have. So we are going to count is 0. We can say color has appears, occurs count times. And then in this loop I want to increment count if, so we have to loop over all the 3 sides. And then if something plus count. Oops. The something being something equals color. Okay, so pieces, well, pieces P, that is my piece. Oh well, let's just add a square bracket operator to get the color. So my piece now must have a color returning operator with square brackets. So it takes an int s of side. That's of course const. And lo and behold, that is easy. Sides s. Maybe not that easy. At least pretty much. Oh, still not. Oh, you don't have an operator equals for color. Seriously? Seriously. For color. You'd think that just having an unequal is enough, but no. Ta-da! And I did something wrong. Blue occurs 5 times and green occurs 3 times. Like I said, I have not much light here. The rest seems okay. I'm looking for my flashlight, but I don't see it. Blue occurs 5 times. So one of these is not it. Which one? Well, probably one of these two, because this is also boy. Well, at least we'll be able to keep one boy. Say blue, orange, yellow. Blue, or that doesn't exist. Well, it is white. Blue, orange, yellow. Yeah, I found it. Totally, this one. So then there is another one. Yeah, we have blue, red, white. That's one at the top. I could solve it already. That would be easier. It's mixed up. Blue, yellow, red. Okay, I'm going to partially solve it because it's way too hard to do otherwise. Okay, where's my yellow one? Here. Let's put this one over here. No, that's not what I wanted at all. That's better. Where's the last one? Yeah. Red. Okay, I made a top layer good with blue on the top. So it is white, red, yellow, orange. Green is not part of it. Oh, wait a minute. There's no blue in it. Yellow, orange, white, orange, white, white, white. Did I say white? Yeah, also. No, then we have to go over all of them. Blue, red, white. Yep. Blue, yellow, red. So I have this one, and I found this one. Blue, orange, yellow. It's this one. And then the last one is blue, yellow, orange. What? No, that's impossible. Oh, that's white. Yeah, see, that's white. That's hard to see. It's blue, white, orange. So this one does not exist. I think I saw that one. Blue, yellow, orange. Should be removed. That's probably white then. No, no, it didn't even help me. I know a solution. Wait a minute. I'm so lazy. Finally, I got up and turned on a light. Oh, that's how it looks like. Okay. Red, white, blue, yellow, red. Blue, orange, yellow. And blue, white, orange. That's all the blues. Bit we are missing a green, because green should be at the front. Yeah, obviously. Green, white, red. That's this one. Green, orange, yellow. Green, orange, white, I mean. That's this one. That was these two. And here we have green, yellow, orange. And green, red, yellow. Yeah, so green, yellow, orange is missing. No comma here, comma, 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 comma here. Okay. And all colors, okay, 4 times. No hot chocolate today. Hey, Post Bunny! I have not, I didn't see you there, yeah. Happy Christmas to you too. Like test. Okay. Is there anything else that we can test? Yeah, like I said, there's always exactly one color that does not occur for a certain block. For example, blue is combined with white, red, yellow and orange, but not with green. Because green is opposite of it. Yeah, there's no green here. There's 2 yellows, 2 reds, 2 oranges and 2 whites. Here the 2 reds, 2 yellows, 2 oranges and 2 whites as well. Well, I think I have it now. These are the pieces. Now, then next we need a cube, I think. Because apart, well, we have colors, sides, pieces. Might as well go for the whole cube now, next. Maybe you should combine piece with the orientation that it sits in. However, if I rotate the thing, it changes also orientation, or does it? Doesn't it not? Guess it does. Each cube is um, hmm. Not bad. I think everyone can guess what 3 is. Yeah, I might as well call this piece. Pieces. But now we have an orientation as well. I mean, this is cube 5, but it has 3 sides. I guess I'm going to do it randomly, as in pick something. The side of these 4, the side that's on top is the one that is called first or something. Or that is the representative for the orientation. And then here I can use for the bottom, they can use the bottom, I suppose. It's a bit long. I'll just call it orientation. Yeah, maybe I should order these things as well, actually. How about the solution will be with blue on top? And I started counting at the bottom, so probably they should go to the top then. And then obviously we start with 0 and then well in the solved state. let's say we do red up front. With red up front, this is piece number 0. It's gonna be green, yeah, green, red, white, or green, white, red. Where green is immediately also the representative, because that's the color at the bottom. Same thing for blue. So if the representative of the orientation is blue, then blue is at the top, which means that the thing is solved. Hi Aerobic. Yeah, it's a 2x2x2 Rubiks. So let's see, well, yeah, green, I had green to the bottom, but now here in my table it's at the top. Oh, I think I should just reorder these things. I'm gonna use this, let's call this 0. Okay, that's a bit too hard. I mean, there's several in them. So substitute so annoying. Four 0. I need a swap. Just swap them. So this becomes 3. This becomes 1. And this becomes 5. And then swap 2 and 6. 0, 0, 1, 2, 3, 4, 5, 6, 7, yeah. And then we put blue still at the top. So this is piece number 0, and with blue at the top, and red at the front. Yeah, so this is blue and this is red. So what is this color on this side? White. So that is the top one, yeah. And then number 1 is blue, yellow, red. And number 2 is blue, orange, yellow. And number 3 is the blue, white, orange. Yep. And then we get number 4, which is green, white, red. And then number 5 is green, red, yellow. And number 6 is green, yellow, orange. And then we have the solution. That is the solved state, basically. Having a cube, the cube as it is filled here is in the solved state. But even if it is not in the solved state, well, that's not true. I would have to copy pieces to these pieces, and the orientation then must be filled with the first color of all of them. Then we have the solved state. Not even sure why I would store the pieces themselves here. That's kind of silly. I just store the integer index into pieces. So this must be equal for all of them. And then, well, if it's not, then well, we know that it is not solved. And if all pieces are in place, and also the orientation must be correct. So yeah, and the orientation must be correct. And the orientation we read from here, of course. So the orientation of P must be equal to the first color of the pieces. So that must be pieces P 0. Let's construct a Rubiks cubic with the default constructor. So basically the same thing as solved, but then we don't test anything. We just put it in there. P becomes P, and the orientation becomes that color. So if now we make a cube, we don't need this anymore. Now create a cube, and we print is solved, then it must return true. Value type sans array int 8 value type, aka int array subscript. Oh, pieces returns an int, yeah. So the pieces array returns an index of pieces or of the pieces array. Cannot convert color to standard array, blah blah blah, e-color. This returns an e-color, damn it. Let's see, well actually pieces returns a color. That's blue. And orientation stores an e-color, so yeah, that maybe this shouldn't. I sound like an OGC dev. What is an OG? I haven't coded in C for decades. No, normally I use sophisticated utility libraries that I have written in the last decades. But this is Christmas, and I promised in the description of the video to do it from scratch without using any library, including my own stuff. So I write everything from scratch, and I don't have time to do it nice. So yeah, it's all ugly. But we still use classes. Grandmaster. I hate auto. Control. Need this end. I can't code. I mean, well, in the end it's gonna work, but you see this kind of shit. What am I doing? How can I get these many errors in one program? Use deleted function. You cannot construct an array. What? My color has no default constructor. I'll have to fix it, I guess. Control reaches end on non-void function. What is this? Oh yeah, okay. Otherwise return true. One, which means, you know, it's true. Yeah, well. So this is bool alpha for alpha bool. I think bool alpha, because it's the most unlogical thing to do. Yep, true. Okay, so now we want to be able to print the cube. And I'm definitely not going to do anything graphical, as if I can do that. So doing everything in ASCII. How do you print a 3D cube in ASCII? In the most lazy possible way. I think we'll just print every piece in order. Maybe 4 on top and then 4 at the bottom. Nah. Let's print this. So we print the piece here first, which is number 3 on oops 0 1 2 3, this one. And let's just print it as the way it is shown there. Then we have to do some brain gymnastics to understand that it is in the right position, but the right orientation. But again, I'm just going to print blue, or was it blue, white, orange. And then for this one, that's gonna be blue. Well, it's not that hard actually. I mean, if it is on the right position, then you can see that it also has the right orientation because it starts with a B. So not that much brain gymnastics is necessary. Okay, that one was number 2, 0 1 2. That is a BOY, my favorite. And then we get this one, 0, blue, red, white, blue, red, white. And then we get 1, blue, yellow, red, blue, yellow, red. Now do some fancy shifting maybe. When does this thing look a little bit like the above? Print it like this, and then the other thing below here. So So that would be number 7. GOW. Number 6. GYO. Yeah, I should be in bed as well. I wonder if I get this finished before, probably not, before I have to go to bed. It's now almost 2 a.m. Okay, number 4, 0, 1, 2, 3, 4, of course. GWRG. I should have started earlier. I was doing something else. I'm sorry. Green. The problem was I was doing something because of which I couldn't reboot. And I had to reboot before I could run OBS. So I just couldn't stream. 5. 765 GRY. Yeah, I mean, I'm not sure if it helps me, but now I would like to number them like 0, 0, 1, 2, 3, 4 in the back, 5, 5. Oh, I got a job offer from God knows where. Well, not so much as an offer as well as they said they thought I would have the skills to join their team, and if I was interested to apply for the job. So I guess then if they see my face, they would still not want me. Just kidding. But you know, yeah. Well, it was kind of a dream job. I could work from home in C++, and it has to do with virtual worlds and artificial intelligence and Vulkan. But the only problem I saw that they especially wanted me for being a Vulkan expert, because I wrote a Linux Vulkan engine. I wrote back a reply in which I pointed out that I do not consider myself a Vulkan expert. But I didn't get a reply yet, because I guess it's the holidays. No, that looks definitely weird, the 7 there. Trying to mimic the same jump as between 2 and 3, with 6 and 7. Might as well remove these, because they're just confusing now. And 4 isn't even visible at all. Not too sure what I did now. I think I swapped front and back. So 0 and 2 must be swapped. And 1 and 3. And then also blue, orange, yellow, what? Yeah. Blue, orange, yellow, blue. Nope, not working. Oh yeah, you can't do that. Can't do that. No, it was still on red at the front, of course. So I mean, we don't change that. So it's blue, white, orange at the top now. And then blue, orange, yellow. And then blue, red, white. and then blue, yellow, red, and then this one, green, orange, white. And then green, yellow, orange. And then green, white, red. And then this one should be green, red, yellow. Yeah. Yeah, I think this is more confusing than that. Might as well print it like this. Looks almost like a cube. Top square and bottom square. Squares on the side. Yeah. And well, there's still the same thing, you see, the order. But now we're going to print that one a bit lower and this one too. And so on. I mean, I don't need it here anymore because you have it there now. And I want to have a function that prints that. Which means top to bottom, hey, we print them in order 0, 1, 2, 3, etc. Which is the piece index, which I call P. Which makes me think at the time that I was in Second Life, which is a virtual world. Nothing is real in that world. It's all digital. But he had a swimming pool there, and someone was as funny to say, no peeing in the pool. They had a pool there, and there was a sign that said no peeing in the pool. So I peed in the pool, obviously. And I was banned. Yep, I was banned from that sim. Sad memories. Some people are just so, but I don't know what, but they have it in their arse. Up, deep, and no sense of humor. Oh, the times I have been banned from Sims in Second Life. for the most ridiculous things that I said or something. Like I can tell you, but then I would have to kill you. I replied to someone, and suddenly it turned out to be the sim admin, and he banned me instantly. It was so obviously humor. I think actually I was sitting there with my friend, and we were chatting, and we were both brats, I guess. So always naughty. We might have been talking about the admin of the server, considering what we saw around us. So just we went to random servers and sims, and then we were sitting there in the 3D world. So maybe we did comment on what I don't know. And then so this guy came to us and he said, "What did you say? What were you talking about?" And yeah, I was like, I mean, either you hear the chat or you don't. It's not like you can hear the words vaguely, but you don't. I mean, it's all typed text, so either he got the text or he didn't. So I thought he's role-playing, right? Well, plus I didn't know he was the admin of the server to begin with. So we replied then, well, we can tell you, but then we'll have to kill you. So yeah, well, no sense of humor whatsoever. I think what he really wanted was that we repeated what we said about what the admin, which we didn't know, obviously. Just, I don't know, some stupid dog humor, maybe. And then he was like, "Ta-da, I'm the admin, and I'm going to ban you now." But since we didn't want to repeat it, he just banned us anyway. And all that because I see the letter P here, and you pronounce it as P. Okay, let's continue coding. Print. Yeah. So we run over all pieces again. Actually, this is just one more story. I mean, you need to know Second Life, I guess. Second Life was or is owned by Linden Lab, which was originally written by Philip Linden, who was I think sold it anyway after 2 years or so. He coded the whole thing in alone, and he launched Second Life, and then he was on to the next project. And he sold it to Linden Labs. And one of the rules in Second Life was that you are not allowed to impersonate Linden. Now, obviously, they mean that you go to some noob and say, "Hey, I'm actually a Linden, so do what I say." Yeah, that's what I meant with this rule. But again, with my buddy, we went to Orientation Island, where all the noobs start, and we had put on avatars that looked like Philip Linden, and so we were just looking literally like how they advertised him. And then we pretended to be noobs that didn't even know how to control the avatar. So we were like bumping into each other and, having no control over the avatar whatsoever, or looking the other way while saying, "Hello, how are you?" with the back to someone. Or, what is this key for? And that kind of silly stuff. And then we were banned at some point with this reason that it was not allowed to impersonate Linden. I didn't know you were that accurate. God. People have no sense of humor. Where did I learn C++? Here? Well, behind my PC. In front of my PC? Behind? I don't know. I think it has two sides, but... Yeah, just by coding, by doing internet. Yeah. Generally. I really have to write some new code. Okay, so I'm running over all the pieces, damn it. And I want to print them by number. So we are at 0. And that gives me a piece, as in I want to have a piece. Const reference the current piece. The current piece comes from the array, the global array. Don't do that at home. Pieces. You can do as index pieces underscore p. And I can print that, no problem. Coded that in, and then we want to have a new line after everything. But yeah, now we don't have any indentation. Actually, it still prints true because I'm not printing it at all even. Blah, blah, blah. Yeah, I want to print it like that. Come on. So we also need a quick friend here. Friend standard stream reference operator less than snore os comma qb cube const reference cube code cube. Every time I type code in my phone, it makes it, the spelling checker turns it into coffee. Every time. I never type coffee. I don't drink coffee. Well, hardly. And I can't tell it to not do that. I wouldn't have. It would be no problem for me whatsoever to remove coffee from the dictionary. But no, you can only add stuff. Warning. Oh god, I forgot to return OS. Yeah, okay, well that's nice and dandy, but where does the last new line come from? I mean, but where's my indentation, right? So the indentation depends on, well, the line. I could even hard code that. Let's hard code it. One, that is the indentation. This one, indentation of 0, is that too ugly? Let's just do it like that. So 2, and this is then 1, 2, 3, 4, 5, 6, 7, 8, whoops, 8, 9, 10. And I have to remember that even. So, what was it? 4, 10, 2, 7, 4, 10, 2, 7. 4, 10, 2, 7, 4, 10, 2, 7, 4, 10, 2, 7, 4, 10, 2, 7. We made it, unless I made a mistake. Standard array int of 4 of them. Indentation is hard coded. Totally const. Not going to change that. This one too. Qualifiers work on everything on the left. So I put const after the standard array because this is a qualifier. It works on everything that is on the left. Okay. Indentation, indentation, indentation. So here we want to print the indentation. I know the indentation, but how convert that to... Actually, let's calculate indentation first. Indentation is indentation P modulo 4. I don't know why you're doing that. Yeah, well, or here. Because I added another global array just to do stuff that is naughty. Santa Claus will not be happy with this. So the indentation now is correct, but now we have to print that many spaces. Yeah, beats me, man. Like standard string or something. I'm tempted to just make a loop and print this one space at a time. But yeah, I bet you can make a string from this by passing a size one way or the other. I'm just going to try it out. This is not working. Well, maybe... What did I do? Maybe the other way around, and then I give up. Then we look it up. And that's it. So you don't have to look it up. See, it was faster. Okay, so no, that's my cube. The solved cube. B is blue at the top and G is green at the bottom. The next step is, of course, to be able to construct my cube the way I have it now, because I want to solve it. Okay. I already have solved the top for most of it. Well, the top layer is solved. Period. So I can even do this one like that. Now only 3 pieces are wrong. And so that would be easy to put in, right? And then put it like this. So yeah. Maybe you can just make the solved cube and then set some pieces. Top cube set. I call it the piece 6, comma. And then the thing that's actually there, plus how it is orientated. I think I'm just gonna give 3 colors. Probably the easiest. So yellow. If this thing, it's a piece at the bottom because it is 6. And you have to start with, for the orientation, with the color at the bottom. So that's yellow, and then clockwise orange, green. Orange, green. So. And if I do 2 more, then I'm done, and then the cube is programmed to what I have currently. So this is the next one. 7 is correct, so I have to set 4 and 5 as well. So 4 is at the back. 4 would be white, red, green. and then 5 is really, I'm doing it again. I think this, see, it's yellow. Yellow no, it was white. Sorry, I was looking at the wrong thing. White, red, green. Yeah. Four. Is that 4? Yeah, that's 4. Okay. White, red, green. And this is 5. That is orange, white, green. Now, I think I got them. Orange at the bottom, clockwise, white, green. Yep, and that is position 5. Yeah. And 4 is white, red, green. Yep. And this was 6 is yellow, orange, green. And that one is correct. So I have to write my set function. Void set, and set is taking the piece, no, it's not a piece, man, that is one of the 8. How can I call these pieces? These are not pieces, these are corners, right? We have 8 corners. Everywhere where you have an 8, it's actually a number of corners. Yeah, we do C. Of corner, it looks like a color. Just no abbreviation then. Corner. No. Oh yeah, actually. So it looks so weird. Corner. How is... yeah, the corner is an index. Index into pieces. Corner. Corner. Absolutely not the readable code. Yeah, assembly, yeah. Loads of things. But mostly a very long time ago. When I was a teenager, I coded in assembly mostly. Because the rest was too slow. Well, later on I wrote sometimes, you know, in a C program also, or C++, if it really had to be fast. I don't do that anymore. Computers are so fast these days that it's not worth the time. Might as well just code it in C++ fast enough. It's the speed is mostly defined by the algorithm that you pick. If you pick a really stupid algorithm, it's going to be super slow. If you're being smart about it, not like this code, This code is horrible in terms of speed. But if you just write it just in C++, and you don't have loops of 1 million and then several inside each other, it's gonna be fast, you know. Just don't do stupid things. So this is a corner. I'm afraid that what I just did, I fucked it up right here, see? I forgot one, so I'll probably forgot two. Set corner. And then we get 3 colors. Can those be colors? Color like this? Yeah, it should be. Should be. So that is the first color, and then the second color, and the last color. Okay, so what does that mean? Well, that means that pieces at index corner is some index, nobody knows which, orientation at the same corner is the representative, which happens to be the first one. The bottom color or the top color for whatever I am passing, and I did that correctly. I did pass them like that. However, so yeah, depending on corner here, and they are all at the bottom, so this is always the bottom color. So it is always green. I mean, if it was solved already. I doubt this is compiling. What is orientation? Orientation stores color. Okay, so I'm trying to assign to a non-const color a color. Oh, that should work. Yeah. This one is slightly more difficult because I have to interpret the 3 colors and then convert them into an index. So if blue means at the top, and then we have white, orange, red, or yellow already. I only need 2 colors, it seems. Or is that nonsense? No, this is nonsense. You need 3 colors. Unless, actually I only need 2 colors. Yeah. 2 colors and their order would be enough to determine which one it is. Well, brute force it, right? So we need a function that returns the index of this array. Int pieces index. Yeah, this contains e colors and enums, but nah, we work with colors. So I'm gonna pass color with the same name as we have, color G2 color C3, and that's going to do the magic and return the index. pieces index. It's the index of pieces. Doesn't look like it if you read it like that. Pieces index. C1, C2, C2, C3. That hates that is called delegating or something like that. Now you order someone else to write this function. We want to do something, we don't know what, but we just invent a function and we say that function is doing what I need. Ta-da! Done. Set has been written. I just only need to implement this function now. But that's easier because that function is defined straight just below our array. So we can now see the array while running this. Very nice. So we're going to run over all the corners. Just corner, less than number of corners, plus corner. So that's the index of my pieces array. And then we're going to test something and then return the index because we found it. And if we get here, there we didn't find anything, so that would be an assert, I guess. Should never get there. I'm gonna return -1 because just in case the compiler is gonna complain anyway, like, you know, reaching the end of a function without returning something. Because you can compile without asserts active, and then it would actually, you know, crash differently than if you return -1 is also crashing. But now the compiler isn't complaining. Okay, but we do need a header for that. Include C assert. Okay. So what comes here? Well, if we found it. When do we find it? Well, well, the caller C1 must appear somewhere. So we're going to have a loop over all the sides of the piece. S loop. And then if we don't find it, so again something, but if we don't encounter C1 anywhere, then that was not it. So then we come here and then we have nothing to do. We just want to go to the next corner. But if we do find it, that means that pieces numero corner, that side equals C1. Ta-da! Ta-da! Is that correct? Because pieces corner returns a piece. My piece must have a square bracket operator. It does, which returns the side, and size was a color. So this is going to return colors, which we can compare to colors. So just color here and a color there. So if now we find it, then we know that at least it has C1 somewhere, right? We don't know where. It could be the first one, or the second one, or the third one. And it is only the correct corner if the next one in the array equals C2. We don't need to look at C3. So it's going to complain about not using C3. So we delete that. So no complaining anymore. Hell, I don't even need to pause it. Why would I pause it if I don't use it? Oh no, this is not using it. Set? Yeah, well, whatever. Well, yeah, nah. You know, maybe you can assert on it if it is not correct. It would theoretically would be sufficient already, but might as well test it. So okay, so here we say if the next corner, whatever that is, equals C2, then we found it. Then we can return corner. But the next corner means, of course, the next side. So this must be S plus 1 then. And then we could go outside of the array. So we have to begin at the beginning. Which means we do a modulo here, modulo 3. So if the thing was already 2, and we add 1, and we start over at the beginning. So now it rotates. So say we were looking for white. This is white, and we find white here. Then S is 2, because, well, that's the third element. S plus 2 plus 1 is 3, modulo 3 is 0. So then we compare blue at the 0th thing, the first one, with C2. And if that then is correct, then we assert that the next one equals C3. Because it really has to be, should be. Oh, return corner. I think this works. Yeah, okay. And it doesn't assert, which means that probably assert is turned on. So we did compile it with assert. Yeah, I think so. You have to actually define something to get rid of assert. To define n debug for no debugging. Of course, you can test it by passing the wrong color. Let's say, while trying to find green, we don't find green because I'm passing something that doesn't exist. Well, the opposite side of orange is red, I think. Yeah. So there will definitely be no red there. Cannot have red and orange on the same piece. Yay, and the assert indeed worked. And the C3 now is failing because, well, that should have been green, not red. Extra check that this worked. So yeah, now you see clearly this is my cube as I have it here on my disk. You thought you were never going to see it because I don't have a webcam, but oh, it's there, and now we have to solve it. And solved would mean that. Wait a minute, this is the solved. This is already the solved solution. Uh-oh. I was gonna say solved would mean that the bottom is starting with green. So this is green and that is green and this is the solved cube. Damn it, what went wrong? Yeah, I'm not that good with OpenGL or anything. That would take me days. And I want to stop in half an hour, so. And then it's not good that we run into, if anyone sees what is the problem here, we construct a cube here in the solved state. Yeah, the default constructor, then it is a solved state, and then I set some three pieces at the bottom, 4, 5, 6, with no green as the representative. Basically, the first one is the color at the bottom, so there is no green at the bottom. White, orange, and yellow are at the bottom here, so this is absolutely not solved. Green should be at the bottom. But it prints it with green as first color, which means green at the bottom. So it's still solved. Version cube not solved, failed. So set is failing. So I call set, and then after that the cube is still solved. Just it doesn't do anything, as if you're not calling it. How is that possible? I mean, if you call is solved, it checks if well, if that returns true, that means that, for example, pieces corner is equal to corner all the time, because oh, wait a minute. Wait a minute. That is not right. What nonsense is this? It should be or unequal. So if the piece is not at the right position or the orientation is incorrect, then immediately we can stop. Well, yeah, that won't help a bit, because it has nothing to do with a set. Oh. What the F? It's still printing it like this, so maybe the printing is wrong. Oh, that was nasty. So if that's true, so is solved was broken, so that it looked like it was still solved, and it prints that it is still solved. So obvious conclusion, set is not doing anything. But apparently there were two bugs that were partially how do you say that? Cancelling out. Yeah, I think that clearly now it says that the cube is solved here and the cube is not solved here. So hopefully I solved is solved. Fix is solved, and the cube is indeed not solved after calling set. But it's still printing the solved version, so printing is wrong, I think. But if I do that, it's going to call this print on, which does this. It runs over all the pieces, and then we get what? No, wait. No. Oh, so it's not solved. It just doesn't print the orientation correctly. Yeah, I'm not even looking at the orientation here. So what it should be printing is green, white, red for 4, and green, orange, white for 5, and green, yellow, orange for the 6. Well, the actual solution is different, and I guess the easiest way to see that is printing it before I scramble it. Well, change those 3 pieces. Yeah. Okay. So this is solved. GOW, and now it turns into GWR. It was wrong to think that it is solved if G is at the front. That only means that the green is at the bottom, but the other colors are still. Yeah, and we have to print the orientation correctly. Now, how to fix that? Print on. This is wrong. So we have to run over all the sides, I guess. First we have to look for the side that corresponds with the first color that we have. That corresponds with the orientation. How am I even printing it? I'm printing the one at the bottom first. It doesn't matter. We just have to find that thing. Okay, so if something, then at least we found the starting point, and then after that we can break out of this loop. Where something means we found the orientation. So something equals orientation underscore corner, I guess. That must be piece S. Yeah, this is the piece, and this is the side of the piece as a color. And orientation also returns the color, the color that we want at the bottom. So as soon as we found that, now we have to print that plus all the so you have to loop over it again, well, or continue looping. We print one side beginning with this one, which we just found. And then the others, again doing modulo 3. Just going around in the array, print all 3 sides, starting with S. But this piece here returns a color, right? And I want to print that color as a character, so as a single character. So let's go to color. Color. Here. That's a single character. We call print on it. Undo, redo. So really, it's just what did I say? Print on. Yeah. Hint on OS. Okay. So yellow is at the bottom. And then we get orange and green. That is totally correct. There's white, red, green, orange, white, green. Yep. It's really easy to see, actually. I mean, I have the cube here, but you can just read it. You know, this is the color at the bottom, and then I look at the thing, and then I go clockwise around the same piece. So this is indeed the current cube. Now, did we get any closer to solving it? No, because at the very least we must be able to turn one side in a certain direction and then mutate the cube. Uh-oh. Not even talking about the brute force stuff that follows. Well, that means that we have 6 sides of the cube, and then rotating it one way is nothing. It's going to brute force it so non-PG that it is that we might as well rotate every side the same direction and not, you know, reversed. So that's 6 possible operations, which look very much the same, but the way I coded it, it's not. Yeah, I'm afraid there's just really no beautiful way with this sucky code that I wrote to not have a lot of code duplication. I feel like I have to do the whole rotation stuff manually almost. I have to define my axis. Okay, let's define the axis as follows. Does it really matter? No, it doesn't. But maybe you should just give them a name also. Name in axis. It's not really an axis because I'm going to have left and right, both, you know, just direction, side, I already use side. It's another side is, I'm going to call it axis, but then do as if it is side, okay? Because we're going to call those things top, bottom, I don't know. Left, right, front and back, because why not? And then the boring stuff, I have to be able to print that again. So I'm gonna have steal the code from here. Yeah, I'm that stupid. I wrote it an hour ago and already don't know how to do that. Like this. Zip. Because, well, it has to look a little bit the same. So anything color is axis. Substitute color axis. And well, why not call this E-axis, because you never know, maybe we'll make an axis later on. axis, and then yeah, chop. Trust me, if I could use my utilities, I would just do AI case return top, and then for all of them. I could even copy this and then paste that here, and then do a substitute boing, dong, boing, ding, doing, ding, dong. What do we get here? Oh, why did I put it in front of it? Oh, it has to be there, or not? No, it has to be there. That's why I did it. Of course. Comma. Well, everything is gone, but yeah, guys, return. Backslash 1. And there it is. But I don't have case return, unfortunately. Maybe I should just steal it. It's not the same as including my own stuff. I can just sneakily copy it from projects. I don't know, go here and then go to some projects. And then grab AI case return, which doesn't occur in this project. Oh, it does. Of course it does. And then jump to it. And then copy it. Because, well, I knew it wasn't just one line. So I thought, hey, might as well sneakily steal it. I think that was even faster than when I had to type everything, you know. Okay, so then, my friends, we can print the axis. Okay. What is next? A member function that operates on the cube. So that's going to be void rotate axis. Totally not const, because this is muting my cube. Very hard to implement as well. Let's define that all the way down here. Member function of cube. Yeah. Well, easy is completely something else. I am going to use ctext though, because I'm getting completely crazy here. It's just one file. And then I think I can do, I'm gonna sneakily look at how that looks. Oh, see, you just do it like that. Okay, it's not the same as using my library. I'm just stealing it. Build there, what is in the current directory now? Tags. Hey, no tags. Oh, we have tags, but we don't have highlighting, color highlighting. I could add a syntax highlighting to the cube as well. But I forgot what that line looked like. There's like one command that I have to run then. Oh, I can steal that as well, of course. Which make? Normally run makes you run this. Okay. And the build directory is just current directory. Nee, it doesn't work. Why doesn't it work? Why does this not work? Oh, yeah, no, why it doesn't work. I need a complete build system for that, which, I mean, actually, I think I would have to look in the configuration of VI itself, which is actually NVim, of course, which is having it in like dot config, isn't it? NVim? Pretty close. Might so this up. This probably refers somewhere to build here. Builder. Yeah, text file. Set tags. No, but I already have that set. No, that was about syntax highlighting. Syntax highlighting. It's another build here. No, it's only build here. Okay, I give up. Too sophisticated. That's good enough. I can jump to cube now. Okay, rotating it. So that means that both pieces as well as orientation are changed. Yeah, I'm tempted to just, just write it manually and then 6 times. Or would that take longer than when I really think about it and more or less automate it? What do you think? For example, what happens if you rotate the top clockwise 1/4? Then index number 0 gets what is currently in index number 2. I'm gonna make a copy of this because how else can I write that function? So we're going to do it extremely bad. Case top. In the case of the top, we get that pieces 0 becomes pieces 2. Yeah, that should be possible to do that quicker. Like we add a function that's gonna do this, and you'll just provide it with the information that it needs. So that it's, I don't know, do pieces, and then we pass the way it morphs, like a permutation. And a permutation means let's say 0. Let's say the current one is this, because that's logical. And now it's going to be changed. So if I call this, it's going to do nothing. And then there's logical thing that you just define the permutation as what 0 becomes. So 0 becomes 2, and 1 becomes 0, and 3. So 2 becomes 3. And 3 becomes 1. Yeah, 0 becomes 2. 1 becomes 0. 3, that's this one, becomes, sorry, 3 is here. 2 becomes 3, and yeah, this is correct. And then suddenly it's not that much work, because, of course, I might as well write the rest. Let's do the bottom first, because that's the order in which, yeah, top, bottom, left, right. Okay, so bottom means there was a rotation clockwise. So from the bottom we rotated that way, which means that, oh, for the, oh, well, yeah, well, it's not that easy. Okay, so this one, and I was assuming that we started with 0, 1, 2, 3. But at the bottom we start with something else. I mean, the bottom refers to, maybe I should pause just both of them. So that is the original, and that's where we go to. And then if you put a new line here and you shift it a little bit, it's even more clear. Okay, so then here we have, and now it suddenly doesn't even matter anymore or how I do it. I mean, let's begin with 4, because 4, 5, 6, 7 becomes, now 4 is somewhere in the back, and we're rotating it now clockwise, looking from the bottom, so that would be that way. So 4 becomes 5, and 5 becomes 7, oops, and 6 becomes 4, and 7 becomes 6. Yeah. Pieces left. Okay, left, left, left. This side here, so we have 0, 2, 4, and 6. So just have pick an order, right? So why not ascending, or what is it? Increasing? Is that ascending? I think so, yeah. And we rotate that way. Yeah, I'm rotating this, I'm looking at it, and then I'm looking at it from the left side, and we rotate it clockwise. So we see the 0 goes there, and the 4 goes to the 0. So the 0 becomes 4, and number 2 becomes 0, and number 4 becomes 6, and number 6 becomes 2. And then this side, pieces. Here we have 1, 3, 5, and 7. Clockwise, 1 becomes 3. 3 becomes 7. 5 becomes 1. And 7 becomes 5. It's just true. It's not as hard as I thought it would be. The front. 2, 3, 6, 7. Now imagine I would not have made my ASCII art. Ouch! Then it would have been hard. Always make very nice ASCII art drawings, children. 2, 3, 6, 7. Clockwise, 2 becomes 6, 3 becomes 2, 6 becomes 7, and 7 becomes 3. And then we do pieces. That is then the back. Aha. Ugh. I'm gonna say 0 because I don't see it, and that, and 4 and 5. And 0 becomes, well, it must be 1, right? Clockwise. 1 becomes 5, and 4 becomes 0, and 5 becomes 4. Because look, it's actually like that. Yep. But yeah, we're not done because also the orientation must be done. So we have to do orientation. How does that work? Well, I have no clue, and I have to go to bed. 3 viewers left. Skip sleep or continue till 6 AM and finish this. As if it is finished then. But okay, well, past halfway, so I think at 6 AM would work for me. 3 more hours, yeah, it should work. Hey, tomorrow is another Christmas day, so maybe you should just stop. I probably should just stop. You know what? I'm going to stop, except that I'm going to do pieces. Or at least make a beginning with it and see how hard it is. For void cube do pieces. And these are corners. Oh. I'm so not going to type corner in full here. We should not call them C at all. Maybe you can call them from to. That would be. This would be the 2 ones then. 2. We move the from ones to the 2 ones. Ish. As of yet, absolutely no idea how difficult this function is going to be. It can't be too hard, can it? 4 lines? That would be not hard. It kind of depends on what pieces. So we have to change pieces. Okay, pieces exist of stuff. Indexes. Contains indexes. Yeah, it just rotates. It's really going to be as easy as 4 lines, I think. So pieces, let's say, if I rotate the top a quarter clockwise, then whatever 0 is currently pointing to by means of containing an index into the global array, it's going to need to contain that afterwards. So we need that pieces 0 becomes equal to pieces 2 and so on. which means that we have to and from. And we need to do that for all four. So why not just define them as an array actually? Standard array int 4 2 standard array int 4 from. And then we can loop over this. I is 0, I less than the size of one of those, plus I. And then this is 2 I and from I. Correct? And then nobody knows how many braces we have to use here. It's always the same with those bloody arrays. There. I'm just going to try to compile it. See where the first error happens. No declaration matches. So that's so annoying. Oh, that's not as annoying as I thought. But it's unexpected. I could have known though. Set is now using 2 pieces. It'd be nice to define that already. And the first error happens. No declaration. What? Again? No functions named 2 pieces standard array. Oh. I just added that. What is it talking about? What mistake did I make this time? We copy this. It's called cube do pieces. Stuff. Stuff looks okay. Standard array was included. Exactly what I did a moment ago, and then it says that it was not defined because I added to something that's not cube or something. I thought this is cube. Maybe totally this is cube. And we have array included. Array included. Two pieces. Standard array int 4 2, comma standard array int 4 from. I don't see a mistake here. What? What? Yeah, why are we getting this error? I declared the member function 2 pieces declared here. Here I try to define it. And then the compiler says error, no matching function. Oh, that's something totally else that I saw before. I don't know. Where's my error? The error went away. Ridiculous. I think I scrolled up too far. That's what I probably just scrolled up to the previous one, which I already had solved. You see, it's a totally bad time. All my viewers run away. No matching function for cube. It's just a call, man. So this is goes wrong, therefore the other ones work. Okay, just one brace is enough. And again. And again. And don't do that to me. Oh, this time it doesn't. And again, and again, and again. Insert, 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 zip, insert, 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 da-da-da-da, insert, what? Back. There's no colon. Yeah. I think that's it. So we did do the do pieces, and then the next thing is the do orientation, and then everything is in place to start rotating. So then we just have to write a brute force thingy to solve the cube. And I'm going to bed now because, well, one late, two, no viewers left. Well, two viewers, one of which sleeping, the other one is, I don't know, AFK. So maybe I'll